Imagine glancing at your smartwatch and seeing this. Earth just shaved off 1.36 milliseconds from today's rotation. And you've missed it. So basically, you blink your eye and you have missed it. For a curious mind, that's like compressing Usain Bolt's starting dash into the twitch of a single neuron. But behind that blink lies a bigger story. A planet spinning just a little faster, pulling technology, science, and even history along for a ride. Welcome to Earth's fastest and forward. Earth's rotation has always bubbled, but since 2020, it has been setting records. For example, July 10th, 2025, the shortest day of the year has been recorded with 1.36 milliseconds less than 24 hours. On July 22nd, 2025, almost as short as 1.34 millisecond. 5th August forecasted to have shaved off another 1.25 millisecond. And the all-time record, July 5th, 2024, the shortest day ever measured is 1.66 milliseconds early. It's tiny, but if your coffee break lost even half a second, would you notice? But before we understand how this Earth is actually rotating faster and eating away from your 24 hours time bit by bit, let's understand how the speed of the Earth is calculated, right? So how do we know Earth is spinning faster? By just a few thousandth of a second. With the most precise clocks and instruments humans have ever built, let's understand how we try to measure the speed of the Earth. Very long baseline interferometry, VLBI, radio telescopes across continents watch distant quasars. The microsecond differences in their signals let scientists track Earth's rotation to microsecond precision. Second is GPS, satellite geodesy. Satellites trace the ground's precision, revealing subtle bubbles and shapes. Third, ring laser gyroscopes. Devices like Germany's ROMI detect rotational down to few nanoradians per second, sensitive enough to notice the planet breathing in time. And all of this is anchored by atomic clocks. Instead of ticking hands or quartz crystals, they listen to cesium atoms flipping energy states. Exactly 91926317770 times per second, and that's not just a measurement, that defines the second. Without this precision, GPS would not find your house, planes could not navigate their route, and billion-dollar stock trades would not synchronize. So, why this is happening? The moon usually slows Earth down. Its gravity drags on the oceans, stretching out our days by milliseconds every century. But sometimes the moon speeds us up. When it orbits, tilts fastest from the Earth's equator, like it did on July 9th and 22nd, 2025, it pulled off the center like tipping a spinning basketball on the side. Each off-axis tap shaves a fraction of millisecond off the day. Tiny, yes, but enough for scientists to notice. Now, deep below us, Earth's solid iron core has its own rhythm. It oscillates a slow heartbeat every 6 years. First revealed by Soviet nuclear test seismic data in 1970s, this swings slightly adjust Earth's movement of inertia like a skater pulling its arms to spin faster. Each oscillation can tweak our day by milliseconds, and the next core swing might bring a cluster of record short days. But not all forces speed Earth up. Like melting ice in Greenland and Antarctica moves water towards the equator, making the planet slightly more bloated, which slows the spin by about 1.3 milliseconds per century. Paradoxically, this slowdown has delayed something extraordinary, our first negative leap second, now forecast for 2029 instead of 2022. The climate change, buying time literally. Sometimes Earth jerks, like in 2004 Sumatra earthquake. Magnitude was 9.1 Richter scale, shifted enough mass towards the axis to shorten the day by 2.68 microseconds. In 2011, Tohoku quake did the same, 1.8 microseconds gone. Even volcanoes can nudge time. When Mount Pinatubo erupted in 1991, the magma drained and ash spread, subtly shifting Earth's weight outward, slowing the spin by a fraction of a millisecond. And believe it or not, even spring leaves add a micro hiccup. So biomass grows outward from the axis, slowing the planet by microseconds. Our digital world expects time to march forward, second by second. On June 30th, 2012, when a leap second was added, Reddit, LinkedIn, and Qantas Airlines crashed. Linux servers froze, flights were grounded, all because software wasn't ready for the clock to read this. Now, imagine the opposite, a negative leap second, where clocks would skip from this to this. No system has ever faced that. It could freeze databases, scramble transactions, a mini Y2K lurking in 2029. A few milliseconds might not matter to you, but they matter to the Olympics. World records are decided by hundredths of a second, timing that relies on atomic clocks synced with Earth's spin. Space launches, for example, even more delicate. Rockets launching get a 460 millisecond boost from Earth's rotation. A shift of just seconds in launch timing could misalign the entire mission, and that is the stake, and that is the repercussions which can happen. Models predict our first negative leap second by 2029. For the first time ever, every clock on Earth would skip a second, and time literally will be deleted. So meta engineers, NASA mission planners, Wall Street traders, all preparing for the second that won't exist. Our bodies run on circadian rhythms, tied to dawn and dusk. Millisecond changes aren't felt. As of now, yet not felt. But researchers wonder, could decades of micro shifts plus smart lighting and shift work schedules create subtle temporal or stress on sleep, mood, and health? It is a food for thought. If you come with any sub informations, please share in the comment section below. If Earth speeds up by 100 miles per hour, hurricanes would roar stronger, oceans would surge, and double the volume. Life as we know it wouldn't survive. No, that's not happening anytime soon. I'm not trying to create an atmosphere of fear, but the fact we can measure these micro changes, milliseconds shaved off by quakes, moon, and melting ice is a reminder. Earth's clock isn't fixed, it's ticking and it's alive. We have conquered gene editing and sent rovers to Mars, yet our clocks still dance to Earth's unpredictable spin. The next time your stream buffers or your GPS hesitates, ask yourself, is it my Wi-Fi or is Earth's heartbeat skipping a beat? Stay curious, keep measuring, because on this rapidly spinning rock, time is never quite what it seems. If you like this video, please like, share and subscribe.